Stephen, you might be on mute. There.
There we go. Did it come off? Thank
Yes,
you.
it did.
Hello and welcome to AWS Made Easy, episode 51. It is live. I'm Stephen Barr, and this is Rahul. And how are you doing today, Rahul? How's the
Everyone.
jet lag?
Yeah, for everyone's context, I just landed late last evening in Seattle. So Stephen and I are not too far away from each other. We wished we could do this in person, but with all my jet lag, I've been up since 1:30 a.m. And so it's been a little crazy. But yeah, looking forward to this week. We have a lot of very interesting and exciting meetings with AWS and a bunch of other customers here. So looking forward to that and bring you some new insights, hopefully.
Yeah, absolutely. It's really fun. We've got some meetings in Seattle, and then what else is coming up?
So we recorded last week. We were talking to Arthur from the Graviton team. We were talking about all the amazing stuff around Graviton, and unfortunately, we ran out of time, and we had so much more to discuss. So hopefully, we are going to have Arthur back with us for the live stream next Monday. And so we're going to have some interesting discussions with the Graviton team. Hopefully, bring some of that to you. Anything else planned for this week? There's just so many things.
Getting ready. It's like we're moving at 1,000 miles an hour.
Correct. But not to mention, we also have the AWS Summit in London this week.
Oh, here, let me share my screen. I'll get that on the screen. 1 second here.
So if you're joining us from anywhere in Europe and you can make your way to London, please join us at the AWS Summit over there. We have not only the AWS Summit where we are participating and we'll be around to talk to everyone. We are also hosting a roundtable with the FinOps Foundation, which is going to be at the event. So if you're a FinOps practitioner, you want to learn more about it, come and join us. There are going to be tons of other folks who are kind of figuring stuff out just like you and like us. And it's a great forum to share experiences, share learnings and insights with each other. So come and join us for all of those events. And we have a bunch of other, side events planned as well. So we are really looking forward to it. You can register right away. Do we have the Non-Sub London? Yep, that's the one.
I'll put this in the link.
Great. So you can register for the event, come in and join us. We are all going to be there in person. I mean, not me personally, but I wish I was there. The rest of the team is going to be there for London. And we're looking forward to it.
And then on the, it's interesting. There's a lot. I was looking through the session catalog today. With AWS events, you can't browse the sessions directly, but you can get their app. And then they have the session catalog. You can see there's more than 70 sessions. Lots of good sessions coming up. There's one about a lot about machine learning, mega trends in SaaS, architecting multi-tenant applications using serverless, power of cloud innovation. There's a lot of neat things going on. I'm looking forward to. And actually, in preparation for the London Summit, I had a chance to reach out to a let's say a notable public figure and chat with them. I didn't realize that they had a cloud cost journey, but I had a chance to speak with them. Do you mind if I share a clip from the interview?
Absolutely. Let's go ahead.
All right. Let's share a clip from this interview. It was quite. I was quite surprised. I didn't realize he had such a cloud journey. But let's share this. Harry, tell us about your cloud spend.
It was a slow, deteriorating situation.
For a while, you were even pursuing a multi-cloud strategy using AWS and Azure. Really?
I think both. I've never seen the level of abuse.
It's a bit of a strong word, but we'll go with it. And there's consultants and different leaders. They have to pursue these complicated strategies, maybe do everything with Kubernetes, manage it all yourself, develop it all in-house.
There's a lot of people that are hired and brought in that ultimately manage that mindset. And I think it's really, really damaging and dangerous.
So you come up with a plan, you're going to transition back to just AWS. How did you confront the CFO?
You have got to put on a brave face.
Fast forward 6 months, you're all in AWS, you're using managed services, you've got your costs under control. What's your attitude to waste now?
I want this to stop with me. Now, for me, I've weaned myself off that because I was slightly addicted to it. and now I have a digital diet.
So I'm heading to London at the end of the week, and I'm trying to figure out what to pack. I'm going to bring my MacBook Air. Do you recommend I take something else as a backup?
Yeah, it is literally that. You have the Air, and then you have the spare. You have the distraction. And if you're not careful, you can really play into that.
iPads can be pretty distracting. Back to cloud savings. Do you ever think, I wish we had started earlier?
It's impossible to say where we would be now.
I agree. It's hard to overstate the importance of saving on your cloud spend. And most importantly, because you can reinvest that money back into the business.
That, to me, has been the freedom that I didn't even know that I was looking for most of my life.
We've got a great blog series explaining behind the scenes how our cost-saving automation works.
There's power in sharing, right? Because then you realize you're not alone.
I heard you tried CDK for a while, but then switched back.
It's like we started speaking a different language.
I'm not a big fan of JavaScript. It makes my brain numb.
Once it's numb, you don't know.
Before we go, we have a big announcement. We're doing a FinOps Roundtable in London on June 6th. And Harry, what's the best part?
You're all invited.
That's right, you're all invited. Well, that is a great place to stop. Harry, we will see you next time. I had no idea. I'm really excited for this trip. It's exciting what the events, the community, the discussions that are coming up. And like Harry said, you're all invited to the FinOps Roundtable.
Absolutely. This is going to be a fun event. So please come and join us in London. We'd love for you to be there, and we'd love to meet you there as well.
Well, awesome. Well, should we get started with some of the contents of our... the article?
Yeah, we have a lot to cover today and lots of announcements that have come out this week. So yeah, let's go through those.
Yeah. Oh, and one other one that I wanted to mention before we actually let me put this back on the screen. We've got, here we go, share screen, window. We just launched a new blog post, the AWS Foundational Skills. This is the new series we talked about last week. And this first one is how to get started with CloudWatch. The CloudWatch is essential to a lot of our finder fixers, how we do optimization, how we gather data. And so it's kind of like the nervous system, I would say. It's where we can get all this great input. And so this is one of our longer blog posts, but it goes through how to deal with the agent, how to configure it, how to make automation to make sure that the agent can actually access the outside world. So making sure your VPCs, where your EC2 instances live, have DNS access, that they have a route outwards. Lots of great content here. It's both theoretical and also, as you can see, actionable. There's sample Python scripts that you can use. There's a lot of great contents here. It's one of our longest blog posts we've written. So go and check that out. The link is in the description. I'll put that right here.
Yeah, and one of the things, we'll cover this a little bit later in this show today as we dive in, but we're calling this the foundational series because there are certain services in AWS that are very fundamental to collecting all the data that we need to operate efficiently. CloudWatch happens to be one of them. There are lots of pitfalls in how CloudWatch is set up in different organizations, how they use it. And so this hopefully will make sure that you have all your bases covered in terms of how you need to set it up so that you can leverage the data in there to get all the insights you need and then use that to operate efficiently. So we'll dive a little bit in detail into all of that stuff a little later in the show. But first, the news.
All right, well, let's jump into it. I'm going to put this back on this. I'll put this window here on the screen, and let's talk about Elasticache for Redis data tiering. Now supports auto scaling. And we're moving really fast today, so I don't have pre-made transitions. So let's just jump into it. Elasticache for Redis data tiering towards auto scaling. So Elasticache for Redis. Rahul, how do you read this one?
Okay, so this one is actually really neat because, again, the more stuff is managed for you without you having to decide how to scale it up or down or right size it, the better it is for overall efficiency, both from a cost standpoint and from an operational standpoint. So I'm very excited about this. I see auto scaling and right sizing or automatic right sizing coming up and being attached to every managed service out there. Eventually, it'll all get to serverless. So this is kind of a form of serverless. It doesn't go down to zero though, but it's a great first step to be very efficient. Almost every service that I know of, almost every service has some kind of a daily or weekly or monthly cycle of peaks and troughs, right? So this is probably one of the easiest ways to make sure that you are scaling up or down to match those workloads for yourself. So leverage it, make it easier on yourself to scale up or down your services accordingly. More and more, I see that there's no point in managing a lot of these services yourself. Like every excuse that I've heard of goes away with every passing month.
That
This is one
comes
of
down
them.
to one of our key pieces of advice: use managed services. And we'll be talking about this at the FinOps Roundtable, but it's no secret. I think people often overestimate the benefit that they get from running bespoke versions of a service, right? They say, okay, I need this special plugin for Postgres, so I can't use managed Postgres. Or I need this special build of Elasticache or a special build of Redis or whatever it is. But often would you say that's overstated?
I think yes, but there's another factor. Invariably, the excuse that I hear about not using managed services is that of cost. Okay. And I think the way the cost is computed has two flaws. One is when you're doing your own self-managed service, you don't account for the cost of the people and the resources that are required to manage this. You don't account for the cost of potential downtime. But most importantly, you don't account for the cost of adding these new features in a self-managed environment that you pretty much get for free with every passing month with a managed service. Like someone who's been on Elasticache already, a managed service, they just got this turned on for free.
Yep. So not even just maintaining the status quo, but just because you're in AWS, you are on the receiving end of this stream of innovation because there's enough, everyone's bought into it. We're all innovating together.
Correct.
And it's not just Elasticache, but on many managed services, we have seen similar announcements, right?
Correct.
Here's a new feature available today at no additional cost.
Correct. Didn't we discuss Event Bridge like I think 2 weeks ago, where they had an 80% improvement in performance in Event Bridge latencies and response times? So if you were hosting your own version of an event router, it would have made no sense because anyone who's using Event Bridge suddenly just became 80% better for zero additional effort. So in the long run, it just helps making that bet.
Whereas if you're managing it yourself, the absolute best case is that you do nothing and it stays up forever, right? In the theoretical best case, which is never going to happen.
Yes.
All right. Well, looking at the specifics of this one, so it's Graviton-based, auto-scaling, Elasticache for Redis.
I think it simplifies, definitely simplifies. So I'd give it a simplifies tag, and I would give this a 4 out of 5.
All right, that is a strong start for AWS today at Amazon Elasticache for Redis. It simplifies and a 4 out of 5. The Elasticache, that's a great service. It's easy to use, and I think it's Redis. Redis itself has done a really good job at not having feature creep and just staying really simple, and that put in a key, get back a value, and it's not trying to become I don't know.
Well, there's an entire Redis suite. So there's a database, there are all kinds of other features. So I wouldn't say Redis is not getting into any of that stuff. But yeah, I think this version of it is fairly simple. And I'd urge everyone to start using the managed service instead of trying to manage their own.
Yeah.
That's a no-brainer.
Absolutely. All right. Well, let's jump into our second article. Our second one is Amazon Athena updates. Let's put this one back on the screen.
Yep.
So Athena updates data source connectors to improve performance and reduce costs. I think this is another one of those updates that you just get for free just for being on Athena. So this is exciting.
Yes.
So
more and more, this is going to start becoming the theme, right? Because like they just updated a bunch of the underlying data connector framework, and it just got a lot better, especially for non-S3 data sources. And you get that for free. So again, simplifies because developers don't need to do anything.
So what is the Athena data source connectors? If people haven't used those before, what are Athena data source connectors?
So think of Athena as your SQL gateway to querying a whole variety of data sources. So you could have your data in S3, in Redis. I think Redis as well. You could have your data in S3, in Redshift, in RDS, in Aurora, in CSV files sitting somewhere, or even an API for that matter. You could have all kinds of data sources where Athena gives you a simple SQL or SQL interface to query all of these different data sources and be able to bring that into something like a QuickSight dashboard, or be able to take that and put that somewhere else. If you wanted to dump the data into another S3 bucket, you could do all of that stuff right out of Athena. It's way cheaper to do this than trying to build your own data lake from scratch, build your own query model on top of it. This is just simple because it's just SQL at the end of the day.
So prior to Athena, if you had a collection of CSV files or JSON files and you wanted to have a dashboard-based view of them, you would have to have some ETL process, which say scanned the source of your CSV files, incrementally updated the database, make sure that you didn't make duplicate records in the database, and then you'd end up having two sources of data that were, well, if you did everything right, they'd be in sync.
That's right.
And that's your hope. But now you can have one source of data and you could have a schema on top of it, and Athena will realize, okay, you can take this bucket of CSV files, bucket of JSON files, and treat it like a SQL database. And you don't have to manage.
I'd say that you would have multiple data sources here. You can have multiple different data sources that are widely, different from each other, and you can still have one common schema that you're querying and just rely on SQL to get the results you want.
It's amazing that SQL has between SQL and Python become these like lingua francas that are doing much more than their original intent, right? The original intent with SQL was, 2 or 3 different database engines, and now it's talking to CSVs, talking to all these other services. And so a data connector then is another thing that Athena can talk to.
Correct. There's a version of, I won't call it a version of SQL, but there's something called Particle that AWS has been working on for a while, Particle. Particle is interesting in that they believe that all of their data sources will be queryable with a SQL compatible query language. And that's kind of the underlying language that they're going to be using to talk to all these different services.
Perfect. I put a link to that in the chat as well. Particle. So an expressive SQL compatible query language. This is, we've seen, what was the other one? Trino. Trino is their engine. In any case, we've seen great innovations in this space to drive, being able to talk to other data sources.
Correct. So coming back to this particular article, I'd say definitely simplifies because you've got performance that's coming free for you. And this is a 4 because from a behavior standpoint, it's no different. You don't have to do anything.
And there's no additional costs.
No.
It's just a new feature that's there if you want it. If you don't, it gets out of your way.
Correct.
All right. Well, let's take a quick break. Then we come back. We're going to review 2 more articles. And then we've got a deep dive into VPC idle NAT gateways. So stay tuned. We'll be right back in about 30 seconds.
Public cloud costs going up and your AWS bill growing without the right cost controls? CloudFix saves you 10 to 20% on your AWS bill by focusing on AWS recommended fixes that are 100% safe with zero downtime and zero degradation in performance. The best part? With your approval, CloudFix finds and implements AWS fixes to help you run more efficiently. Visit cloudfix.com for a free savings assessment.
All right, we are back, and we've got AWS Compute Optimizer supports external performance metrics in 5 new regions. So Compute Optimizer, that is a neat tool in and of itself, which just quickly should summarize what Compute Optimizer is. It's what gives you recommendations on instance sizing, instance typing, by basically looking at your CloudWatch data and looking at AWS's historical patterns and giving you recommendations on basically how to make your infrastructure more efficient, how to save. On the right sizing recommendations, we use Compute Optimizer in the background to look at right sizing suggestions. And it's a great service. Rahul, what do you think of Compute Optimizer?
Yeah, so Compute Optimizer is something that you should definitely take a look at. The Computer Optimizer is available not just for EC2, but it's also available for Lambdas and also for EKS that was announced 2 weeks ago. So take a look at Computer Optimizer. It's an easy way to kind of get a bunch of very interesting recommendations. Where this one is interesting is a lot of customers actually have external data sources where they calculate the CPU utilization, memory utilization, and all that other stuff. So you're now able to bring this in from those four providers. And I really wish that they would extend this platform to bring in other pieces of data that can influence the right sizing. So, for example, what happens to your throughput? When you're receiving requests and stuff. So, to be able to track that and then make decisions around what's happening to the real world application, not just IO, disk and CPU and memory, that would be useful in creating checks and balances for right sizing. So overall, this definitely simplifies. I brought this one up because I wanted to make sure that we reiterate using the Compute Optimizer. It's a way to make sure that you've right-sized. A lot of us end up over provisioning whatever resources we set up for our applications, and there's a good check in place to make sure that you aren't over provisioning and you've just got the right set of resources.
That makes a lot of sense. And it's neat that you have these 4 different partners: Datadog, Dynatrace, Instana, and New Relic. So that way, if you're gathering all this data, you're not managing 2 parallel data pipelines. And I guess it's neat of AWS to recognize, okay, not everyone is using maybe the native tools, but that doesn't mean they want to duplicate effort either.
Yep.
And I put in the link just our link to our EC2 right sizing, but that's showing how Compute Optimizer is used. I'll put this on the screen quickly. We did a deep dive on this just a few weeks ago, but this is what the output from Compute Optimizer looks like. So you can call the command AWS Compute Optimizer get EC2 instance recommendations, and it will produce an instance, and it'll tell you, okay, here's the average CPU and memory, and here's some recommendations for what to do. Here's a new instance size that can perhaps save you a certain amount of money. And because the CPU and memory are over provisioned, so it's too big for the load it's currently experiencing. So that is Compute Optimizer. And so now, just to summarize, we get this Compute Optimizer, which can gather data from external partner data solutions like Datadog or New Relic and take that in as input data. And I guess in order to make it into this partner program, they must have to qualify to show that data is accurate and timely. So the Compute Optimizer is making good decisions.
Exactly. Okay. Did we give it a score?
No,
this is a 4. I give this one a 4 as well.
All right. So far, pretty good.
They're on a roll.
All right. Well, we have one more article to share, and this one is AppSync. That one doesn't come up as often.
That one hasn't come up in a while.
So AWS AppSync merged APIs for GraphQL Federation.
Correct. So this has been a long awaited, GA feature. Let me just start with GraphQL. So traditionally, we've used REST API as the backend, to talk to any UI or whatever else. GraphQL kind of emerged as a really neat solution for exposing data because the UI is in control of the schema that kind of is returned back. Because in the query that you present, you say, here's the data that I want back, and you get predictable results. And from a UI standpoint, in an API, you're not pulling out all the data irrespective of what you need. With GraphQL, you can get back only what you need for the UI, and therefore the communication is very, very efficient. Now, the other really cool thing that I liked about GraphQL and the promise of GraphQL was that under the hood, you could actually federate out queries to different data sources, bring them all back, and then return them to the client when they were asking for it.
So as an example, so say you had an online shopping cart, right? You might say,
Right.
select all items in cart, and that might be one REST API call. And then for each item in the cart, get the image and the description. And then so on the front end, you have to do this loop. Whereas what you want to say in GraphQL is, give me my order with my items and then an array of descriptions and images. And
Yeah, so this is more like you're giving a nesting example, but let me give you a different example. Okay. Let's say that you were basically querying one schema for certain kinds of data. Or let's say, take the example of the shopping cart, right? Let's say the shopping cart had to also be tied with credit. Okay. So you say, get me the shopping cart details. And then in parallel, you're also making another query to get all the discounts or any amount that's sitting in the wallet. You want to bring that all at the same time. So you can basically federate out two separate queries to two different subsystems, bring the data together, and then present a combined view to the user for the query that they have, which is, I want the shopping cart. I also want the details of how much money I have in the wallet, what are the discounts that have to be applied, and so on. So all of that can be done in a federated way, but you bring back all the data and return the data back to the customer.
got it. And I think I like this because it also kind of more cleanly separates what's the front end and what's the back end. And so you don't
Correct.
have logic creeping into the front end that really shouldn't be there.
Exactly. So that's where GraphQL becomes really, really neat. You can post for a specific query that gets you specific kinds of data, really efficient to do that. And at the behind the scenes, if you need to federate and get data from different data sources, you can do that. And now this AppSync now supports these merged APIs where you can actually federate out your queries behind the scenes and then merge the results to return them back to the customer or the client. You can now do that with AppSync, so which is really neat. It's been long awaited.
That is pretty exciting. So does this work with Amplify?
So Amplify is, think of it as the front end library that will
Okay.
allow you to access the GraphQL API. It generates the GraphQL client for you, no matter what your UI technology is or your front end technology is.
I think I was too early an adopter of Amplify and had a few rough starts, so I didn't follow it up. So I want to give that another try, because I think the idea of Amplify is that you define your data models, it would automatically build out this DynamoDB schema and give you a GraphQL front end, a GraphQL interface to your DynamoDB tables that you could then use. But I think it was a lot all at once.
Correct. I would agree with that.
So merged APIs. So this has been in beta for a while?
Yes, this has been in beta for a few months now, and it's now finally GA.
Let's have a look at the how-to blog quickly. Let's see. This just came out a few days ago. Okay, this is giving you the example you're saying. There's a book reviews, which is looking at a books API, a reviews API, authors API, and users API that could have different backend data sources. And auto merge is showing how this query can then talk to different services. This is great. I really like this this blog post with this is a very lengthy blog post. Lots of good examples, how to use the UI.
Correct. But this is exactly what we asked AWS for, right? I mean, we've been asking them to create these very, very easy to getting started guides. And this is perfect. I was reading through this earlier today. I absolutely loved it for the detail. The fact that there's a how-to blog right up front is awesome. It'll help someone get started with this immediately.
So, how happy are you with this whole thing?
Very happy. I'd give it a 4.5 or a 5. I would give this a 5 for its comprehensiveness. And this is exactly how I would like every announcement to be.
Well, this is a landmark moment. 5s are rare. So that's congrats to AWS. This is neat. And I'll definitely have to give AppSync and Amplify another try. I'm not much of a front end developer. I tend to get it's just not my cup of tea. But I want to give it another try because I want to see where it's come. And this merged API seems really neat. I want to give that a shot.
Yeah. So I think that concludes our announcements for today. Should I take a quick break and come back onto the deep dive?
Yeah, let's do it. We'll be right back.
Is your AWS bill going up? CloudFix makes AWS cost savings easy and helps you with your cloud hygiene. Think of CloudFix as the Norton Utilities for AWS. AWS recommends hundreds of new fixes each year to help you run more efficiently and save money, but it's difficult to track all these recommendations and tedious to implement them. Stay on top of AWS recommended savings opportunities and continuously save 25% off your AWS bill. Visit cloudfix.com for a free savings assessment.
All right, here it comes. Okay, let's get the displays organized here. Let's take this off the stream, and then I'm going to turn on. There we go.
We need a different view.
Yeah, I want to do the. There we go, and then turn on my chroma key. 1 second here.
Do I see a picture in picture?
Oh, that's what it did. Off, and then there we go.
There we go.
Perfect. Thank you. This is cleaning up idle VPC NAT gateways. And the blog post, it is on cloudfix.com, the cloudfix.com blog. So make sure to have a look at that. And let's just jump right into it.
Yeah.
So VPC, it's virtual private cloud, and it's about logically isolated virtual networks. Now, this is like all network components. Whether it's a security group, subnet, routing table, elastic IP, NAT gateways, you can build and change all of that via an API. And so a long time ago, this would be in the domain of people who had to get into their Cisco routers and learn these esoteric languages to program all this stuff. And it was difficult for a non-expert to do this. And so it's really neat that these are now all available via API.
Correct.
It was interesting. I was thinking about this subject matter, getting ready for this blog post, and I was looking at our old network diagrams back when we first had internet access, and we had an entire Class C to ourselves, which was kind of neat. And then at some point we realized, okay, this is not what we want to do. So, and also the ISPs got more stingy with their IP addresses. So we ended up buying this Sonic Wall device, which was our first NAT gateway, and that gave us, that allowed us to implement NAT and have make use of our now only 8 public IP addresses we got. So I found this interesting when I was doing this research. So I looked up kind of the history of NAT, and we're doing this just as a background to get into what are NAT gateways. For comprehensiveness. It's the history of NAT. I thought this was interesting. So in the RFC, which is like the request for comments that's made by the IETF, the Internet Engineering Task Force, it said the biggest problems facing the IP internet are IP address depletion and scaling in routing. And so it said this is a short-term solution, which is NAT. And the idea is you place network address translators at the borders of stub domains. So the idea is you would have, like, say if you had some company and you would have like internal.company.com, and then all of your office computers would be behind internal.company.com. And it's interesting, kind of rewinding back to the original premise of the internet, because it made me kind of reflect that we almost forget now that the idea was that every computer would be publicly routable to every other computer. So if you had an office computer and you wanted to talk to your friend's office computer, you could just, they would each have public IP addresses, and you'd be able to route back and forth to them without needing to kind of go through some third-party intermediary service.
Correct.
Then when
that's changed so much.
Well, and then they realized, okay, the IP address scheme supported about 4.7 billion IP addresses. They wanted every person on Earth to have a computer. It's more than 4.7 billion people, plus all the devices. We all have multiple devices, so that wasn't going to work. So NAT was proposed as a way to save public IP addresses, but it also came with some other, I suppose, benefits to security as well. And so now we use them not just for the preserving of IP addresses, but also for security purposes.
Correct. So if you remember, about 20 years or a little over 20 years ago, a lot of the conversation had already started about IP addresses for IPv4 kind of running out, which is kind of why IPv6 came about, with the idea that if you needed to do something like that, you could continue. But in the grand scheme of things, we still aren't ubiquitously using IPv6 as a common practice. We're still all on IPv4 for the most part.
Yeah, no, I went down a little bit of a research rabbit hole for an hour when I was on this blog post, thinking, why aren't we using IPv6? And what would the internet look like if IPv6 was the original design specification, and then we would have never had to invent NAT?
Yeah.
It's different.
Correct.
So here is what a VPC NAT gateway looks like. This is the logo. I know this is a dark purple, so it shows up strangely. Let's see if I can offset. There we go. So this is what a VPC NAT gateway looks like. So you have 3 gravitons in a VPC NAT gateway. They've got private IP addresses, and this is using the standard 192.168.0. That's the standard private class C. And then the NAT gateway would have an internal private IP address, and then an external public-facing or public with respect to some larger network IP address. And that would access either the internet or that larger network. And so why would you do this? Why would you set something up like this? Well, one of the advantages are, like we said, saving IP addresses. But another advantage is security. If you have connections from the internet going in, it's not going to route them to anything inside this private network. So another advantage as well. And so we've almost conflated what a firewall is supposed to do and what a NAT gateway is supposed to do in terms of blocking inbound connections.
Correct.
So that is what a VPC NAT gateway is. We can create one of these via API, configure it to our heart's content, without ever having to hook up a serial port to a Cisco switch.
Yep.
All right.
And I just add, by default, now in AWS, when you want any of your VPC instances to talk to the internet, you will need a NAT gateway.
Yeah, absolutely. Otherwise, they will be private and they'll be able to talk to each other, but not anywhere else.
Yeah.
Rahul, can you talk to one of the benefits of VPCs are reducing data transfer charges? Can you explain that to our listeners in terms of why that is?
Yeah. So VPCs, as long as you keep traffic within VPCs, within an availability zone, the traffic charges are 0. So you wouldn't have to pay anything for it. As soon as you go inter AZ, there's a certain amount of charge that applies. So, and then if anything goes over the public internet, it is treated as egress cost, and you actually get paid. You get charged 2x what the charge is, because on one end, when data is flowing out of the NAT gateway, it is treated as egress, so you get charged for data flowing out of the AWS network, and then over the internet when it comes back into another VPC, over there, because data is going through NAT gateway, you get charged for the NAT gateway charges, data charges as well. So you kind of get hit twice when stuff goes over the internet. So you have to be very, very careful about how you architect your network in such a manner that the vast majority of your network traffic, especially for systems that are talking to each other internally, keep them within the same VPC ideally, or at least within the same, even if they're different VPCs, get them peered in a manner where your network charges are zero, and only use the NAT gateway to send out data that is going to be used or consumed external to AWS.
So imagine if every time you walked out your front door but walked in your back door, you paid a fine.
Correct.
It's essentially that situation. And so you want to make sure that you could stay inside the network. And so by using VPC NAT gateways, it's like circumventing this fine that you would otherwise pay.
Correct. Exactly.
So how do VPC NAT gateways then become idle? Well, one way is they can be left over from the development and testing process. It's really easy to point and click and create resources and associate them together. But without a mechanism, there's not an easy way to then remember. I mean, unless it's in your mind and you didn't write it down, or you didn't use tags, or you didn't use a CloudFormation template, then there's no mechanism tying all these things together.
Correct. Very often what happens is that, especially when it comes to network, right, there's typically a network ops team that'll set up the basic subnet for you with the appropriate VPCs and the peering, or you might be part of a more complicated network setup. So there's typically a team that sets up the subnet and the VPCs for you, and your CloudFormation stack or your infrastructure as code would basically just cover everything above that, assuming that your VPCs are already in place, because that may not be completely in your control depending on how your organization is set up. In a lot of those cases, as you tear down your application, everything is torn down except for the VPCs and the gateways and everything else that was set up for routing within the VPC and the internet.
Yeah. So that makes, so that's perfect sense. It's just the separation of concerns leads to this kind of abandoned resource. And similarly, if you set up some resource and then you shut down the EC2 instances and you think, okay, I'm responsible for those. Maybe I get charged back for those. So you shut it down, the service is retired, the network infrastructure still stays up.
Exactly.
So then what cost are we thinking about? Well, it's $400 a year is what a VPC costs. Then we think about, how do they actually add up? Well, in an application, you would have multiple VPCs per region, multiple regions per account, and then so it actually is a multiplicative of 400 per year. And so if an application went out of usage, it could be many multiples of this $400 per year that you would save across all the idle VPCs, across all the idle regions, across all the idle accounts.
Yeah. I think more than that, for me, it's more a hygiene thing where some of these things like idle NAT gateways are also an indication that there's some disconnect between what your ISC stack looks like or how your application is deployed versus the underlying basic networking infrastructure. And you want to close that gap. I think if you see a bunch of idle NAT gateways in your setup, you want to go address that root problem and make sure that you're covered for that. The costs in some cases might not be that big, but it points to a more fundamental underlying problem around how you're set up operationally between your underlying network setup and the application setup on top of it.
Yeah, it's a good exercise to say, is everything that I have managed by infrastructure as code or some other systematic process? Could I take any asset and query it and understand what application is associated with it? That's
Correct.
Something that you want to work towards over time.
Exactly.
So eliminating VPC idle NAT gateways, of course, sponsor this video, Rahul, founder of CloudFix. This is the easy way to do it. Use CloudFix. Our Finder Fixer will find it for you. It will say, hey, look, here's some idle VPC NAT gateways. You want to click this button and make them go away, and your bills go away. And you can just click that button. That is the easiest way to do it. But like we talked about, with Prince Harry, there's benefits to sharing. We want to share. We all gain from it, and let's share. We want to share what we're thinking about, our approach to eliminating idle VPC NAT gateways. If you want to implement this yourself, or if you just want to see how it works behind the scenes and what we're using to do it, please follow along with a tutorial. So here's the steps we need to take to manually delete our idle NAT gateways. So we have to list them all. Then we want to determine which of the NAT gateways in our list are idle, and then delete those. So it's going to come to our starting point, as the starting point with many of them is the cur. So this is what you want to do. You want to list all of the NAT gateways. Now, NAT gateways, they incur both a fixed fee, so that $400 per year, and also a flow-based fee based on the amount of data going through them. And so if you have a NAT gateway that has that fixed fee and not any kind of flow-based fee, you could say, okay, well, if they're not charging me, then nothing's going through it. Therefore, it's idle. So that's the logic behind this query. So in this query, we're looking at things like NAT gateway hours. So that's the hours that it's been running, or NAT gateway bytes. And you can see that in this line item filter. We're looking for either of those two things. So let's look at what this looks like. And notice also in this query, we're looking at 31 days of data. That's one range. You can pick it to be longer or shorter, depending on how aggressive or conservative you want to be with this. We find 31 days seems like a reasonable trade-off for us. So here's what some output would look like. And look at this, the third line item, we see $0 charge on the NAT gateway bytes. That's going to be our indicator that it's idle. So looking at that one right there. So you can see we have this data. We could either filter within the query or we could filter afterwards, but we can build up this set of line item resource IDs of NAT gateways that we want to eliminate. So now we want to delete them. So the two API calls that we're going to use for that are describe NAT gateway and delete NAT gateway. So describe NAT gateway is just a confirmation. We believe in redundancies, especially when dealing with network infrastructure. So we're going to double check, make sure that it does exist, that is it public or private, and then if it meets our double checking with our, if we can double check, make sure that it's something that we do want to delete, then we're going to delete that NAT gateway with the delete NAT gateway API call. So here's what the first call looks like. You can call describe NAT gateways and you pass it a list of NAT gateway IDs. It's going to return you back a standard, very descriptive JSON. And note here on this allocation ID, this is your elastic IP address that's associated with that NAT gateway. And we also have a finder fixer for idle elastic IP addresses. Those also cost money. That's another one of those things that you want to clean up. You could delete it at this time, or you might want to hold on to it if, say, that IP address was associated with some trust. Like if you were running an SMTP server and you've built up trust with that IP address over time, maybe you want to hang on to that for other reasons. But just be aware that this is also associated with elastic IP address spend via that allocation ID. So once you have double checked, make sure this is something you want to delete using the attributes from that previous API call. You want to call delete API gateway, and that will return you back this status object. And then eventually you can keep querying the describe endpoint, and it will eventually tell you that it's gone. It'll eventually vanish from that list once it's gone. So it'll just takes a few minutes to delete. So that's how we do it. Again, this is the easy way, is to use CloudFix. That will eliminate idle NAT gateways for you. So please reach out to either Rahul or I if you want to know more about that.
Yeah, right. What we try to do at CloudFix is try and automate a lot of this stuff. It's cumbersome, it's error prone. So by automating it and hardening it, we make it really simple to execute. Some of these simple fixes, they are no-brainers, and would love for you guys to explore it.
Yeah, absolutely. And it's really about when you have that cost savings, you have infrastructure that really represents what you're trying to do. Like you said, that hygiene, making sure you don't have other bits of infrastructure, especially network infrastructure that's not documented. That's a real I don't want to use too. It's dangerous in a sense, right? You have ways in or out of your network that are not well known or understood or documented. You want to make sure to get those cleaned up, and you don't want to pay for it. I mean, $400 per thing adds up pretty quickly, especially when you multiply it out over regions and over accounts.
Yeah. I mean, these are things that I would effectively term as FinOps debt. We're all familiar with technical debt as it is associated with code, but this is FinOps debt, which is a similar concept, but a lot of the infrastructure that you let lying around and you don't have the hygiene to kind of, make sure that they are secure, non-wasteful, all of that stuff. Over a period of time, they don't just add complexity to your operational efforts, but they have decay, like services decay. There are overheads that keep adding on as AWS services evolve. And eventually it will not just cause operational complexity, but it'll also cost you money, because each one of these resources, as you leave them on, cost you money. So it's always better to have hygiene where you have, when you say you're tearing down something, every aspect of it gets torn down. When you're saying, I'm going to stand something up, you're standing it up from scratch.
All right. Well, thank you, Rahul. I think this has been a really fun way to present this VPC idle NAT gateway cleanup. All right.
I agree. Thank you for doing that.
Yeah, my pleasure. This is it's been great. It's a great show. We're at the end of the hour already. I always think, we'll never make it through. At the beginning of episodes, we'd plan for what I thought we'd be 20 minutes in and have nothing to talk about. And for the last 50 episodes, we have never, ever, ever ran out of talking points, and I don't see that happening anytime soon.
Correct. Anyway, thanks all, everyone. We look forward to seeing you next week.
Yep, thank you for watching. Please reach out if you have any questions, and hopefully we'll see you at, if not London, then one of the other summits. Check out the links in the descriptions and on our social, on LinkedIn, on YouTube, and please follow us there if you haven't already. It's for more cost saving ideas. All right.
Thanks, everyone.
Bye-bye.
Talk to you soon. Bye.
Is your AWS public cloud bill growing? While most solutions focus on visibility, CloudFix saves you 10 to 20% on your AWS bill by finding and implementing AWS recommended fixes that are 100% safe. There's zero downtime and zero degradation in performance. We've helped organizations save millions of dollars across tens of thousands of AWS instances. Interested in seeing how much money you can save? Visit cloudfix.com to schedule a free assessment and see your yearly savings.